All right, geometry lesson 50. Today we're going to be talking about geometric mean. Mean is an average, right? That's what we're used to seeing the word mean show up as. We're going to look at it today in terms of triangles, altitudes of triangles. So when an altitude is drawn from the vertex of a right triangle's 90-degree angle, or that perpendicular, or whatever you want to call it, to its hypotenuse, it splits the triangle into two smaller right triangles that exhibit some useful relationships. One, it divides that right triangle into essentially three similar triangles. So we could look at proportions where those triangles are concerned, but we don't even have to do that per se. So some of the stuff we'll look at, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to each other and the original triangle. Let me see if I can draw you a picture here of what that might look like. Let's say that I have a right triangle here, and I draw an altitude line that looks something like that. Okay? That line, that red line, is what we're looking at, is creating a geometric mean. But you'll notice that because it's an altitude, right, it's drawing to this hypotenuse back to the vertex, so it's the height of the triangle. Imagine another way to look at it is let me see if I can do this. Is if we saw it like this. Imagine the same triangle but drawn like that, reoriented. Okay? Can we kind of see that? All right. What ends up happening is that this triangle, this small triangle here, this little bit bigger triangle here, and the whole triangle are all similar to each other. Okay? Which means, of course, the right angles are all congruent. And all the other corresponding angles are congruent, and the sides are all proportional. So what you can actually do is you could take the big triangle, where you see this right angle. You could take the medium-sized right triangle, and you could take the smallest right triangle, and orient them all the same way. Basically dissect it, take it apart, right, and put their side links in their corresponding positions, and being able to find missing side links by looking at proportions. That's what I've kind of done in the past, is you take something like this, split it into three separate triangles, and then solve the proportions. Does that make sense? But it gets really kind of confusing because you're having to do you're kind of having to do some mental gymnastics to mentally take it apart and then flip some things so that everything is facing the same direction. You see what I'm talking about? All right, so you're taking something that's visual there and having to mentally kind of cut it and then reorient it. So if it was something that was sitting there in front of you that you could manipulate, it'd be a lot easier, but you're trying to do that all in your head. And I see a lot of students really kind of struggle with that. Okay, so in a triangle like this, triangle JKL, for example, triangle JMK. Okay, so this triangle right here is similar to triangle LMK. So LMK, they're similar to each other, meaning that they're proportional. Okay, they're not the same size, but they're proportional, and both are similar to the big triangle there. Okay? All right, but sometimes the means of a proportion are equal to one another, and this is a special kind of proportion that can be used to find a geometric mean of two numbers. The geometric mean for positive numbers a and b is a positive number x, such that we get something like this. This is what we see whenever we see a geometric mean, meaning that this x, the geometric mean of this proportion is x. okay? And it will always be bottom left of the ratio and top right of the ratio set in the proportion. That's the geometric mean, okay? Questions up to this point? Okay. So the corollaries are what's going to make our lives a little bit simpler in terms of solving some of these triangles. If the altitude is drawn to the hypotenuse of a right triangle, then the length of the altitude is the geometric mean between the segments of the hypotenuse. So that's really confusing without having a visual to look at. So let's go ahead and draw a right triangle here and see if I can't make some sense out of this. So if we have this, just like what we've seen before, right? If the altitude is drawn to the hypotenuse, that's my blue line. Granted, my picture really kind of stinks, but it'll work. Then the length of the altitude, that's this length right here, is the geometric mean between the segments of the hypotenuse. So let's say that this segment of this hypotenuse is 3 and this segment is 4. Okay? From here to here is 3. From here to here is a distance of 4. Okay? So if I didn't know what the altitude was, or let's say I knew what the altitude was, but I didn't know what one of these lengths was, right? The proportion that I would write for this is 3 over x equals x over 4. Okay? And so I could solve for the altitude. I'd get 3 times 4 is 12. And 12 would equal x squared. And so I'd find the square root of 12 to find the length of the altitude. Does that make sense? Okay? But sometimes, you know, I might know different parts of the information. Right? I might know what the geometric mean is without knowing what one of the lengths of the altitude is. I might know that this is 5, but I not know what that is, right? In which case my proportion becomes 3 over 5 equals 5 over x. Does that make sense? Okay? So I wind up with 25 equals 3x, and I divide 25 by 3 to find out what that length of that segment is. Do you see how we're using geometric mean in this situation to solve for specific cases? Yes or no? Okay, to me, the video is going to be really helpful here to go back and look at some of this. All right, so that's corollary 50-1-1 and how it can be used. Then we have corollary 50-1-2. It says if the altitude is drawn to the hypotenuse of a right triangle, then the length of a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that's closer to the leg. So let's take this a step back. Okay. All right, so let's pick a leg here. It says that the length of the leg is the geometric mean. So let's go ahead and let's talk about this leg down here. Okay. There are 2 legs to any right triangle, correct? All right, so I could use the bottom one over here. I could use the one up the side. Okay, we're going to use the one at the bottom for now, and that's going to be the geometric mean between the hypotenuse and the segment of the hypotenuse that's closer to that leg. So let's use 3 and 4 again. Okay, and let's look at how to use geometric mean to solve for this. So x would go here and here, right? It's the geometric mean. Now notice this, between the hypotenuse and the segment of the hypotenuse closer to that leg. Okay, so whenever it says the hypotenuse, it means the whole hypotenuse, right? Okay, what's the whole hypotenuse? 7, right? If this red length here is 3 and the green length is 4, then the whole hypotenuse is 7, okay? All right, so it's the geometric mean between the whole hypotenuse and the segment of the hypotenuse that's closest to this leg. Well, what's closer to this leg, 3 or 4? 4 is. All right, so if I wanted to know what the length of that leg was, and I know that that blue line is an altitude, then I know that my leg here is the geometric mean to the hypotenuse and the length of the hypotenuse closest to the leg. So then I would go and get 7 times 4 is 28. equals x squared. Find the square root of 28. And that's going to be the length of that, right? Right? And just like we did in the other one, right, we looked at two cases, correct? So what if I had something like where I knew that this was 5, I'm just making up numbers, but I didn't know what this was, right? Could I find that? Okay, well, what's the geometric mean in this proportion? Huh? No, what's the geometric mean? What goes here and here? 5. 5 goes there, okay? Because what we've said is that that leg is the geometric mean. So that's the first part I want to fill in, is the geometric mean, because it fills up 2 out of 4 spots, all right? But it's the geometric mean of the length of the hypotenuse. What's the length of that hypotenuse? No, it's not 7, because I don't know that this is 4. 3 plus x. Not 3x, because we didn't take 3 times 4 to find the hypotenuse. We took 3 plus 4. So it's 3 plus x and then 5 over x, right? Okay? So here I'm going to distribute. So I'm going to get x squared plus 3x, right? Equals 25. I'm going to solve for x from there. Does that make sense? So we're going to have some algebraic situations that we're going to have to continue. We're going to need to know what this says, but we're going to continue to set it up exactly the same way. Okay? Just because different parts are missing doesn't mean that we throw everything out the window and make up some new way. Right? We stick with it. Okay? Just because we have different unknowns doesn't mean that we change the way we operate. All right, does this make sense up to here? Okay, I'm kind of trying to take my time because when we get into the actual questions, some of these look really complicated. All right, so that's it for this. Let's move into some questions. Okay. It says find x, y, and z. Okay? So let's start off with x. Can we do that? All right. Do we still have our notes up? Okay. Which corollary, the first or the second, would I use to find x? 50-1-1. Okay. So Chandler, help me out here. What's the geometric mean that I can use to find x? No? No, read corollary, or do you think you got it? No. You're jumping back and forth between corollaries. Michael? Okay, 10 over 5. 10 over 5, because what is the geometric mean for corollary 50-1-1? What are you using as the geometric mean in that corollary? No. The altitude. What's the altitude in this question? 5. So where does the geometric mean go? Bottom left and top right. Okay? And what is it the geometric mean of? Right? You've got it there. You can read it. It's the geometric mean of what? No, read it. Don't make stuff up. Read it. The segments of the hypotenuse. What are the segments of the hypotenuse? 10 and x. All right, it's a short day, right? Okay, so we got to stop there. But read the corollaries. Don't just guess at it. Okay, read it. Break it down into parts. Okay? All right, you guys have trouble with anything? Let me know, text me, or whatever, email me. I guess you can't really text me, but...